Seawater and groundwater are treated to make them potable, and the table below shows information about the composition and treatment of seawater and groundwater. And you can see we've got seawater for this column, groundwater here, and there's the concentration of sodium ions and chloride ions before the first process, and then the concentration of sodium ions and chloride ions after that first process. We're told that seawater is desalinated during process 1, and we've been asked which pair of concentrations could represent X in the table above. And we've got various combinations of 0.003 and 0.5. Well, process 1 is reverse osmosis, and this, we're told, is desalination. That means simply the removal of salt. And we need to know that salt has the chemical name of sodium chloride, and that has the formula of NaCl. And so if we're removing salt, we're removing sodium chloride. And if we're removing sodium chloride, that means the sodium ion content and the chloride ion content are both going to go down. And at the beginning, the sodium and the chloride ion content is 0.5 moles per cubic decimeter. So both of these need to decrease in order for desalination to have happened. We can't remove one ion without the other during desalination. And so, in fact, the first answer is the correct answer. 0.003 is the only option where both of those concentrations has gone down. The sodium has gone down here, but not the chloride. And this time the chloride's gone down, but not the sodium. And actually the last one, neither of them has gone down. And so desalination is the first row. And then we've been asked to explain why the concentrations of sodium ions and chloride ions in the groundwater are unchanged by process 1. And so process 1 this time for the groundwater is filtration. And during filtration, the water is passed through a filter. And what a filter is a series of holes that will allow particles through, provided they are small enough to pass through the filter. And when you are filtering something that is dissolved, the ions are very, very, very small, and so the ions are small enough to pass through the tiny holes in the filter. And that's because they are dissolved in the solution, or you could just say that they are in the solution. And so filtering or filtration only removes solids that are insoluble, not the solutes that have dissolved in the water. And then for part D, we're asked to explain why the groundwater in the table above requires process 2 before the water is safe to drink. Well, process 2 for groundwater is the exposure to ultraviolet light. And actually that's fulfilling the same purpose as adding ozone to the seawater. Both of these are done to sterilize the water, and that means to destroy the microbes that are in the water, the microorganisms. And so we need to eliminate these microbes because they are harmful to our health, or we could simply say that they are pathogens, because by definition, a pathogen is a microorganism that can cause harm. And so to get both of these marks here, we need to say something like the water needs to be sterilized, or what that process involves, which is killing or destroying the microbes. And then the second mark is for saying the consequence of not doing that would be that these microbes would cause harm. After treatment, the groundwater in the table above is sold by a company as pure water. The groundwater in the above table is not chemically pure because the water contains sodium ions and chloride ions. And we can see that here. They're there after process 1 in very, very low concentrations. And exposure to ultraviolet light will kill those microbes, but it won't do anything to the sodium or the chloride ions. And so we've been asked to suggest what the company means then by pure. And what they mean then is that it is in its natural state, or it only contains natural substances that are always found in water, or that in its unadulterated state. We could also approach this from a separate angle, and we can say that it's not been contaminated or that there has been nothing added to the water. But the best answer is pure means it is in its natural state. And then we're told that chlorine is also used to treat some groundwater. That's to sterilise it. That's another mechanism for destroying those microbes. And we've been asked to describe the test for chlorine gas and give the results. There's 2 marks here. There'll be 1 mark for each. The test for chlorine gas is to use damp litmus paper. And it's really important that it is damp litmus paper. And what the chlorine does is it turns this paper white. Or we could say it bleaches the paper. And this makes sense because actually chlorine that has been dissolved in water is one of the components of bleach. And so saying that the chlorine is bleaching the litmus paper is very literal. But that's why the paper needs to be damp, because without it, the chlorine would not dissolve in the water and would not interact with the paper. Sometimes for chemical tests like this, you cannot get the mark for the result unless you get the test correct. I think if you said litmus paper rather than damp litmus paper, this would be an exception. You would be able to get that 2nd mark, but you would not get the first one unless you said damp litmus paper.